Good day. My name is Foto Chidi. I'm going to be presenting to you the design report that I did for my TPG 3701 a, road project. So I'm going to take you through it. The road that we're going to be designing is a road of 3.8 kilometers located near Pomaray, and it's going to be upgraded to a 4 lane, and it's going to be a divided pavement. The design speed for this area for this road that's going to be designed is 80 kilometers per hour, and it is a category B road. The subgrade CDR is 13.051%, and it is categorized as SG2 as per table 16 of TRH4. The recommended road here is a cement treated base pavement. As I take you through this report, you will see why this cemented treated base was chosen. And integrated drainage and erosion control measures were also incorporated when designing this road. And the software that we're using for modeling and designing the road was Civil 3D. It was also used for documentation. Uh, the road that I was designing is located in Pomaray, Msinga municipality in KwaZulu-Natal. Currently, there is an existing 2 lane gravel road which is poor due to all weather access. And the objective of this design report is to improve the connectivity and enhance safety during maintenance. And below in yellow and green shows where our road is going to be located. The design data here, the proposed lane width for the road is 3.7 meters per lane, and the crossflow of the road is proposed is 2.5%, and the total length of the road is 3.8 kilometers. The design life of the road is 30 years, and the design speed of the road in our design is 80 kilometers per hour, and it is a category B road. In the subgrade classification here of the road is SG2 as per table 16 of TRH4, as the CBR falls within 7 to 15%. The manual vertical curve calculation as per TRH 17 as follows. Here is the summarized information that was used. The first uh, the first slope that was used was minus 0.021, and the second slope that was used was 0.031. The length of the curve was 172 meters, 172.305 meters, and the beginning of the curve change was 1,870 meters, and the beginning of the vertical curve elevation was 1,080.968 meters. And as we conclude the calculation, the elevation on the side curve was found to be 1,243.588 meters. During this design, I ensured that there was compliance with the stopping side distance as well. In the report, there is a spreadsheet that was used that fully details the calculations that we undertook in the manual vertical curve calculations. And the paving structure for this road was that the subgrade delineation was that an average of CBR of 14.1.85 was used for the site, and then the standard deviation was 1.134%. Therefore, the design CBR was calculated to be 13.051 using these standard deviation and average CBR. According to Table 16, as mentioned earlier from TRH4, the subgrade of the road is classified as HG2 due to the CBR of 13.051%. Yeah, as mentioned earlier, the software that was used was Civil 3D, and now I'm just going to quickly take you through on how I designed and in this road. So firstly, what you do before you do anything, you set up your drawing and the digital terrain model surface. And then after that, then as shown here on the below image, you import the survey points and create a kin model from there. You import the survey point to create a kin model. And first, the other step that you use when designing the road using Civil 3D, that you define the horizontal alignment and the vertical profile. Here below is an image that shows the finalized vertical profile with cut and fill elevations and with the changes as well. And finally, when using Civil 3D, you build a corrector and extract sections from there where they're going to show the cut and fill of the road. Here is a typical layout, partial layout of the road for the Pomeroy uh, gravel road that was designed. And below also is a typical cross-section drawing of the road where the sections were cut at 80-meter intervals. The traffic analysis for this area was found to be 1,135 vehicles per lane per day, and the traffic class was determined to be falling under ES10, as the E8 is between 3 to 10 million. Therefore, we adopted ES10 for the design. The pavement alternatives for this road, firstly for the granular base, we used 40 ASIL, and we used a 150 G1 base, a 200 C4 south base, and 150 millimeters G7 upper. And the cement treated base, we used an S over 30 A0 with a 150 C3 base, 300 C4 sub base, and as well as 150 G7 upper. And the hot mix ultra was a 30 millimeter surface, a 80 millimeters binder course, a 300 millimeter C3 sub base, a 150 G7 upper. And the cement treated base, according to this pavement alternatives, was recommended as it had an optimum cost and durability as well. The drainage concept for this road was on the surface. I included a 5% crossflow, a 1% shoulder slope, and side drains that's going to drain water to avoid erosion of the road. And the soft surface drainage concept was to introduce 900 millimeters reinforced concrete culverts at depressed inlets. And the erosion and sedimentation control measures were they include sediment fences, riprap inlet, and aprons. And below is just the typical sediment control measures for outlets and inlets for drainages. And the next step here and conclusion is that our road was determined to be compliant with TRH4, TRH17, and SANDRA standards. And the central And the cement-treated base pavement is recommended for durability in these high rainfall areas of our road. And the next step now is to finalize the detailed drawings, the BOQ, and the tender documentation. Thank you.